In this episode of Boxer Tech Garage, I'm going to show you how to take a cylinder head that looks like this and make it look like this. Alright, so welcome back here to the channel. What I have here in front of me is a B25 head from a 2004 STI, and this cylinder head came off of an engine that had been overheated, presumably due to a head gasket failure. So this head has some warpage to it. In the last video I showed you how to measure the gap that is on the cylinder head, and I also showed you what the tolerance is for warpage for these cylinder heads. So what we're going to do is we're going to prepare this cylinder head to go back onto the car, and we're going to use some DIY methods of milling the head without having to send it to a machine shop. Now, first things first, I want to show you guys this cylinder head here. And like I said, in the last video, I showed you what the tolerance was for it and what the warpage factor was on the cylinder head. But I want to take a look at the valves here. And this is the exhaust side. And you can actually see that this valve is actually open just a hair. Now, I've already released the valve springs on the other side of this head. And I want to show you that this is a common thing that will happen, that the exhaust valve will actually get carbon buildup on it to the point where it no longer makes a positive seal. And you can see that right there. There is a lot of carbon buildup right there, and there's also a lot of carbon buildup inside the valve as well. So that's causing it to not even go down inside the chamber here the way it should. And this is not a bent valve either, and I'll show you how to tell that later in the video. So the first thing we want to do is I'm going to disassemble all the valves from this, and we're going to put this cylinder head on the jig so that we can start to mill this by hand. So the first thing we need to do to get it on the jig is we need to take out these exhaust bolts. Now, I'm actually only going to be using this hole right here and that hole right there on the jig, but it's quite simple to take it out. These are a thread pitch 1.5, so I'm going to use 2 bolts that fit this. It's a M14, I believe, is the size of that for metric. So I'm going to use a larger bolt on the bottom and a smaller bolt on top. And what I'm going to do is I'm going to tighten the larger bolt onto the smaller bolt as such. Then I'm going to, let's zoom in here. Then I'm going to use the wrench and turn the stud out. And you can see both are turning, and turns the stud right out. Now you can get these, you can purchase these studs aftermarket that have they will have a hex on there that will allow you to do that. So I'm going to go ahead and take this one out using the same method, and then we're going to attach it to the jig. Alright, for the next part we're going to use just a regular engine stand. I have it set up so that these 2 posts are equidistant for the 2 bottom bolt holes for the exhaust side of the head, and I'm going to use 2 bolts that match to the factory spec, and one goes in one side and the other in the other side. Give me a good tighten up. And And on this one that I'm tightening, I'm using a 1/2-inch socket on there. That's just a junk socket because the bolt that I have is just a little too long and it needs to be able to go in there properly. So as you can see, we have the 2 posts right on the exhaust manifold side of the head. The head is now mounted on the engine stand, and we have the valves removed, and we're going to start to clean this mating surface up. So this is the part most people are going to find controversial in the process, is the method I use to flatten the heads. This is a proven method. People have used it in the past. Yes, I know that a machine shop will do a great job on getting the heads milled, but this is a junkyard motor. So we're going to be using the following items. We're going to be using some 3M high strength 90 contact adhesive. We're going to be using 60 grit sandpaper, and we're going to be using some penetrating blaster. What I'm going to do is, these sheets have to be positioned on this board. Now this board is something you'd find like out of an entertainment center or something like that. These are usually planed as a flat surface. I've checked it with the straight edge, and the surface is completely flat, so this is going to be a good platform for me to start with to adhere the sandpaper to. I've also screwed in some 2x4s on the underside to the board here, and this will serve as a guide so that the sandpaper doesn't walk and we get an inconsistent grind. So what I'm going to do is I'm going to flip these over on their back, and I'm going to put the contact cement on the back of the sandpaper. And just like painting, I'm using a 3/4 overlap method. I'm going to let it sit for probably about 10 seconds, and then I'm going to adhere it to the board. All right, so enough time has elapsed. You can tell it's going to try to come up onto your finger as you touch it, so that means it's good and tacky. So what we're going to do is position it probably 50% one side, 50% to the other side. And we're going to match these two up here. No overlap. And we're going to press. And make sure that it stays. There we go. So we're going to let this sit for probably about 2 minutes, and then we'll come back and perform the next step. All right, so it's off to the side, and what I'm going to do is I'm going to clean the head using just some regular brake cleaner. And we're just going to use some shop towels to clean the surface, make sure there's no dirt on the surface of the head. And give us a nice clean surface to start sanding. All right, so now the surface is cleaned, it's ready to be sanded. We're going to use some PB Blaster, and we're going to douse the head surface here on all the contact points. And then we're also going to do the same thing on the sandpaper that we just adhered. And then we're going to flip it over, we're going to center it. And I have 2 bricks. This will provide enough weight to keep the board in place as we're moving back and forth, and prevent it from actually lifting and causing an uneven surface. So we're just going to move it gently back and forth on the surface. making sure that it does not lift. And since this is aluminum, this is going to grind very fast with a 60 grit sandpaper. Okay. Periodically, we're going to check the surface to make sure that we're not going too far. Remove the bricks. We're going to flip this over, and then we're going to clean off the contaminants that are on the surface. And already, you're starting to see a difference. These black parts that used to be around the edge are starting to go away. And we're going to start to see it looking like this all the way around. Now, these are lower spots that need to be machined more. And once you have a nice shiny surface on there, you will switch to the next grit of sandpaper. So I'm going to continue on until this is shiny here. Okay, so I've made probably 3 or 4 passes across the head surface here. And you can see that there's still some areas here. Now this is corrosion. Now it's not good when you run across the surface and your fingernail catches it. Now this is pretty smooth here. But this here, I can definitely feel that. There's no pitting on the surface here, but it is corrosion. This is generally when somebody uses a chemical head gasket sealer, and it corrodes the areas around where the coolant journals are on the head gasket. So, moral is, don't use chemical head gasket sealants or any head gasket sealant at all. Now, after each pass, I've been cleaning the head surface with brake clean and also cleaning the sandpaper with brake clean, just to get any contaminants off of it, any extra flake from the sandpaper off of it, so that it doesn't keep grinding into the surface and create grooves. And so far, so good. If I take my straight edge now, I'm going to grab my straight edge and my feeler gauge set to 0.05 millimeters. She can't get under there. A little bit there. And a little bit there, but before you could actually go completely underneath that, but just setting there now, that's pretty good. That's almost to where we need it to be. I can get just a little bit of the feeler gauge underneath that and underneath there as well. This method is also good when you have a cylinder head that does not have any warpage, that just needs to be cleaned up. You can actually use some 220 grit sandpaper using the same method and clean the head surface, make it nice and clean for the new head gasket to seal properly. So I think after 3 or 4 more passes, this is going to be perfect here, and then we'll move on to cleaning up the valves and the seats as well. Alright guys, so we're going to take a look at the valves. And what I'm going to do is, I'm going to show you guys this valve here. Now, this valve here is an exhaust valve. And you can see there's pretty heavy deposits here on the valve. And this is the part right here that actually goes into the valve guide on the cylinder head. Now, what typically will happen is this carbon buildup here will start to make its way up and will start to push the valve guide out of the head, and that's why we measured them in the earlier video, and to make sure that they weren't pushed down further than they should be or pushed up further than they should be inside the head. But you can see there's a lot of carbon buildup on this valve right here. And so what I'm using to clean these up, I'm just using my power drill, and I have it set to the high speed setting. And basically all I'm doing is I'm putting the valve into the chuck, and I'm just tightening it down so that it's snug, so that it won't move. And I'm taking a very medium grit sandpaper, probably around a 250 to 300, and running it along the surface here from right where the seal, the valve stem, or the valve seat seal is on here, all the way up to this black area right here. And the process takes probably about 2 or 3 minutes per valve, and when you're finished with it, this is the outcome. And you can see here, this is now smooth right here, and the corrosion, or I'm sorry, it's smooth right here, and the carbon buildup is now removed. It did not touch the seal surface here, and I just lightly went across this here and on the head of the valve. Now, you can buy new valves for a naturally aspirated engine for right around $50 to $100 for the set of 16. But these STI valves will run you probably around $200 to $250 for the set. So, if we take a look at why you should really do this and why you should really take the carbon off of here, I want to show you a valve that I did on a STI motor a couple years ago. And you can see there's a complete chunk missing from this valve. And if you look at the other side of the valve here, it's actually eaten away and started to melt this valve. Now, this cylinder got so hot, this was a cylinder 4, this got so hot that it melted this valve. And these valves are sodium filled, so that means that inside here there is a sodium solution to help keep these valves cool during the exhaust cycle. And the carbon buildup combined with a lean fuel mixture caused it to become super hot in the cylinder temperatures and cause it to melt this valve. And unfortunately, it actually melted the valve seal, or the valve seat as well, on the cylinder head, because you can even see here, it ate into the valve seat surface here. And that's what happens when these valves aren't properly cleaned. And just to give you guys a sneak peek, this is the car that STI, Junkyard STI motor is going into. So, we're definitely going to have some fun with this. Like and subscribe to the channel, share the videos, and we'll see you next time.